Welcome to the Joy of Math with Mr. G. I am Mr. G. I teach math. And I am also Michael, the artist. This easel was made for me by my mother when I was but a small child, and I said, I want to be an artist. And then the world made me into a math teacher. And you know what I did? I said, I refuse to do math without art. And that's what we're going to do right now. We're going to do math and art together the way they were always meant to be. This lesson is free online if you're interested. I did not create it. It is a free open source curriculum online that I absolutely love called Open Up Resources. Check this out. This is from their unit on 6th grade math about dividing, specifically, I'm sorry, I said dividing. I meant decimals, but I'm not going to restart because that was a happy accident, and Bob Ross taught me that. That's why I named this octopus after him. This is Babs Ross. Anyway, I'll get into Babs more later. Maybe. I don't know. So you have to stick around and see. I have ADHD. Who knows what I'm going to do? But today we're going to do a lesson called Do the Zeros Matter? And it's all about adding and subtracting decimals, but not just with boring algorithms like lining them up like you see here. But I want to show what it looks like visually. So let's take this example of 26 hundredths plus 7 hundredths. In the diagram, each rectangle represents 1/10 and each square represents 1/100th. They're talking about this diagram down here. Very confusing to me. Instead, I'm going to talk about it on this diagram. I want you first to know and trust me implicitly when I tell you that this whole rectangle has a value of 1. I wouldn't lie to you about that. I would never. I'd feel too guilty about it. It would keep me up at night. I'd say I lied to those good people on the internet. This whole thing is 1. Not just this box. Not just this box, the whole thing. You know what I'm going to do? I know what you're thinking. You're like, Mr. G, would it be possible for you to highlight the entire box so that I know what you mean is 1? Yes, it's this whole thing is 1. 1. And I know what you're thinking now, probably, because I'm a mind reader. Your marker doesn't work, and you're right. I'm going to throw that away. But what you're probably also thinking, perhaps, is that, well, it looks like that one whole big square is broken up into little small squares. And that's what the problem's talking about over here. When it says each rectangle represents 1/10, that decimal there, oh, gross. You know what? I'm sorry about the performance of my markers. I'm a professional, and I should be more prepared. Thank you, Blue, for showing up for work today. This is called 1/10. That decimal and that fraction, we say their names the same way. They have the same name because they're the same number. They're 1/10. And they're telling us in this problem that each rectangle down here has a value of 1/10. That looks like this in the diagram. It's one whole column. And the reason we call it 1/10 is because if I were to shade in this piece over here, that would be 1/10 of the whole square. And remember, the square is 1. So this is 1/10. Why would I call it 1/10? You're asking. I can read your minds, remember. I would call it 1/10 because it is 10. There are 10 of them in the whole thing. So if this is 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, there's 10 tenths, and 10 tenths equals 1 whole. So this whole thing could be called 10 tenths. Okay. Got it. Now, again, this is also equal to that. This is the problem with math. All these numbers running around with the same value, different names, people calling them the same thing, even though they look different. Same thing. 1/10. There's 10 of them in the whole square. 1/10. Okay. Next, it says, each square represents 1/100th. This over here. So now I'm going to color code this and write this up here. The decimal form of that number is 1/100th, and the fraction form of that number is 1/100th. I should have lined these decimal points up. That really bugs me. You know what I'm going to do? Check this out. This is called thinking on your feet. When you have ADHD like I do, sometimes you have to make decisions in the moment, and this is what happens. So I didn't line up these decimal points correctly, and that was bugging me because, you really got to do that to compare the numbers. So now I'm going to scooch this over here, and now you can see the difference between 1/10 and 100 because the decimal points are aligned. So like 0.1, 0.01. The ones are in different places. That's why this is 1/10 and this is 1/100th. If you didn't know that, I'm glad you do now. So I'm going to label that in our diagram. Why would I call it 1/100th? I'm going to write the decimal form here, 0. 0.01. 1/100th. And then here I'll write the fraction, 1 over 100. They're all the same thing. 1/100th, 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 1/100th. Okay, so the reason I'm calling them 1/100th is because you guessed it, there are 100 of them in here. How do I know that there's 100 of them in here? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, there's 10 here. Oh, that must mean that 1 over 10, or 1/10, is equivalent to 10 hundredths, which we can also write as 10 hundredths. 1/10, 10 hundredths. Let me put the 0 in front. Okay. This is bothering me that it's written smaller. I'm sorry. Sorry to have failed you here. You know what? But art, happy. I wrote the decimal again. I wanted to start with the 0 and then the decimal. All of these numbers are the same. 1/10, 1/10, 10 hundredths, 10 hundredths. They all have the same value. That whole thing there. Okay. Whew. That was a lot of setup. But it's worth it because now we're going to add and calculate the value of 26 hundredths plus 7 hundredths. Okay, so this number 26 hundredths, I'm going to think of as 2/10 plus 6 hundredths. Because that is the same. And I'm going to prove it to you now if you don't believe me. I'm going to color in 2/10. Are you ready? Are you ready? I think you're prepared. These are silky crayons, and they're my favorite thing to color with. I think Bob Ross would have loved these. 1/10. Now I shall go in and draw another 10th. Okay, that's 2/10 that have been colored in. Now it says that I'm going to also add 6 hundredths because this value says 26 hundredths. Here's my 20 hundredths, also known as 2/10, and now I'm going to add to that 6/10. No, 6/10 would be 1, 2, 3, 4, 5, 6, and then that would be 80 tenths, or 8/10. That would be 80 hundredths. No, I want 26. Okay, I'm going to stop talking, because you get it. You get it. Do you know why I'm stalling? Because I can't find my red silky crayon, but it's okay. Oh, I found it just as I was about to give up. This is why you don't give up. 1/100th. 2 hundredths, 3 hundredths, 4 hundredths, 5 hundredths, 6 hundredths. Now I have the number 26 hundredths because 26 of the 100 small cubes are filled in. And again, I could also think of that as 2/10 plus 6/10. Very, very cool. How can I add this number to it? What is that number over here? I want to do this amount, which was my 26 hundredths, and I want to add to it 7 hundredths. That means I've got to fill in 7 more of the hundredths. Just to make sure I'm not confusing you, I'm going to switch to this maroonish color. It's still red for hundredths, but I want you to kind of see the difference between the ones I've already colored in and the one I've started. So you can tell these are the 6 I colored in before. This is 1, 2, 3, 4, 5, 7. Okay, 1, 2, 3, 4. Okay. All right. Now, here is where you're going to do something called the bundle, which you'll see down here, and which you see as the carried 1 over here. When I add all those hundredths, when I had those 6 hundredths and then the 7 hundredths together, I filled in an entire tenth. Because 10 hundredths is equivalent to 1/10. So when I look at this value, I have 3 tenths and 3 hundredths. Please forgive me. I really don't know what came over me there. I just was so excited that the algorithm matched my visual because people always want to use algorithms and I don't really like those. What I like is visuals for math, and I like when I can connect the algorithm that I was taught as a child with the visual that I see before me now. Because I understand the visuals, but I memorize the algorithms. So I like when those two come together. In this problem, it says find the value of 38 hundredths, which I will write above as the fraction form, just so that we get used to seeing those together. Those are the same thing. Plus 69 hundredths, Why do math curriculums insist on using this number? Do they not know the age of the children that I teach? So we're going to add these two things together by drawing a diagram. And can you find the sum? That always means the answer to the addition. The sum is like the added thing. Okay, without bundling. Remember when we bundled before? When we bundled before, it looked like this. I zoomed in a little too much. So you see there where we bundled all of these hundredths in to make a tenth? They're saying, can you do this problem without bundling? And let's take a look. Here before you, I have represented, we're going to go this one step at a time. Our numbers, again, are 38 hundredths plus 69 hundredths, and let's take a look here. Here I have 38 hundredths. Here is 1 tenth, and 1 tenth. And here is 1 hundredth, 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 1 hundredth. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 30 hundredths. So 38 hundredths. Because again, 1 tenth is equal to 10 hundredths. If I broke this up into 10 little pieces, I'd have 10 of these little pieces over here, but I don't want to do that. That's a lot of work. So I'm going to add to that 69 hundredths. I'm going to start with these tenths over here. That's 1, 2, 3, 4, 5, 6. So these up here represent 60. Ooh, why am I writing this so small? Represents 60 hundredths. Well, you can't even see what I wrote before. There it was. Okay. So do you see down there the little 60 hundredths that I wrote? It's beautiful. So now I'm going to bundle. Why am I going to bundle? Because I still have those 60 hundredths. I still have these pieces over here. I have the 9 hundredths of before because I have 69 hundredths. I have 6 over here, but then I've got these extra little bits that didn't make another tenth over here, and I'm going to bundle 10 of them together. There's 9 here. I'm going to take 1 from the 38 hundredths, and I'm going to scooch it over, and this whole little bundle over here forms a nice group of 10 tenths. So let's see what that looks like in our diagram. What? Now I have the 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths that I got from adding 3 tenths and 6 tenths. And this extra tenth I have made from bundling my 10 hundredths. So now I've got another bundle. Look at that, it's a bundle. So now my 10 tenths, do you know what this whole thing made? 1 whole 1.0. Good old number 1, because I have 10 of these things that we call tenths. It would be like if I shaded in this whole thing that had 100 squares. That whole thing is shaded in because 10 of the large rectangles are there. And what do I have left over? 1, 2, 3, 4, 5, 6, 7 hundredths. So you can see that here. Here's my 1 whole, and I have an extra 7 hundredths left over. That means that if I were to add 38 hundredths plus 69 hundredths, using the standard algorithm that you may know and love, 8 hundredths plus 9 hundredths would give me 17 hundredths. Carry over the 1. 6 tenths plus 3 tenths is 9 tenths plus 1 is 10 tenths. Carry over the 1. 1 whole plus no holes is 1 whole. 1 whole and 7 hundredths is our answer. Here it is, 1 whole and 7 hundredths. Oh my goodness, the joy of math. Look at it. Feast your eyes upon that. Isn't it glorious? It's glorious. But what about when you have numbers in the thousandths, Mr. G? I know how to add tenths and hundredths, but what about thousandths? Let's think about what a thousandth would look like in our diagram. Again, this is a square that is representing the number 1. What you see before you is the number 1. So each of these little pieces is 1 100th. If I take one of those 100ths, let's go this one up here. Let's go up here. Well, any of them. If I take any of them and I chop that little piece into... If I make that into 10 pieces, each of those would be worth 1,000th. So let me draw a 1,000th upon this here. So if this represents 1 100th, then I would break this into 1, 2, 3, 4, 5, 6, 7, 8, 9, Go back to the beginning because I made that a little too big. And then 10. Let's pretend those are exactly 10 equal groups. Each one of those little tiny rectangles that I shade in, that would be 1/1000th or 1,000th if I write it in decimals. Because there's 1,000 of those in this whole drawing. There's 10 in here. There's 100 in here. And there's 1,000 in here. So 1/1000th. The fraction relationship that I'm seeing here is that 1/100th is equal to 10 1,000ths, which makes sense because this number in decimal form is equal to this number in decimal form. 1/100th versus 10 1,000ths. Whew! Okay, so let's now go back to our addition problem. The larger square represents 1, the larger rectangle represents 1/10, the smaller square represents 1/1000th. What addition problem do you see here? Okay, well, I see the number 1. I see the number 1. Now, down here, I see 1/10, 1/10, 1/10, 1/10, 1/10. 1, 2, 3, 4, 5. That's 5/10ths, so I'm going to write that as 5/10ths in the tenths place. Then over here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9/100ths in the hundredths place. Okay, so this number here in the top blue, I am going to write as 2 and 59/100ths. I could also say it as 2 and 5/10ths and 9/100ths, but when we say the number together, I just call all of this piece here 59/100ths, because again, this is 10/100ths, 20/100ths, 30/100ths, 40/100ths, 50/100ths, 51, 52, 53, 54, 55, 56, 57, 58, 59. So we call it 59/100ths, but when I look at it, I really see 5/10ths and 9/100ths. But that's something that a lot of teachers don't mention. Okay, so we have 2 and 59/100ths. And then down here, on the bottom number, I notice we have 1, 2, 3/10ths and 1/100th. So I would write that as 31/100ths. Because I have 30/100ths right here, 10, 20, 30, 31. Okay, so 31/100ths. Now when I add those together, let's see. I'm going to start by adding up the hundredths over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, okay, so these over here make a group of 1. So this is 1/10. So I'm going to draw it over here. So now let's count how many tenths we have. I did not draw that very beautifully, but you know, if you want to draw it more beautifully and then post it on the internet, that would be wonderful. Well, I don't mean that sarcastically. I mean that genuinely. Nothing would make me more happy than seeing more fan art of mathematics. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I see 9. I see 9/10ths. 9/10ths. 1, 2, 3, 4, 5. The 3 that we had here. So 5 and 3. And then the 1 that we made by all the thousandths. So that's 9/10ths, and I have my 2 wholes. So I believe the answer to this question, 2 and 59/100ths plus 31/100ths, is 2 wholes and 9/10ths. And we have no leftover hundredths. That's very cool. I like that. Wait a minute. Oh no. Oh no. Oh no, what are these? Oh, I didn't see those. Those are thousandths. There's thousandths. There's thousandths. This number is 2. This is thousandths. Oh gosh. Okay. So we had 2 thousandths here in our original number. So I still have 0. Okay, I still have 0. Okay, I have 0 here. And 2. Okay. 2 wholes. 9/10ths. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 0/100ths, because we have no more of these left over, because we've combined all 10 of them to make a 10th. But I have these 2 little things. You can see, look, I'll zoom in. You see, they were there. I could barely see. I got excited when I made 10/10ths. I forgot that there were 2 little thousandths down there. a 001 and a 001, a thousandth and a thousandth. So that was 2 thousandths. But it's okay. So I'm going to put that 2 in the thousandth place. So our answer is 2 holes, 902 thousandths. Why is it 902 thousandths? Because I broke these each into thousandths. There would be 900 here, because this would be 100, 200, 300, 400, 500, 600, 700, 800, 900, 901, 902. The joy of math. Beautiful. I was going to do subtraction in this video, but this is enough. I'm just going to do addition right now. I need a break. Have a great night.